Everyone doing okay today? Hanging in there? I put up a review. Or is it time? No, I still have a minute, I guess. We can talk about the Cowboys if you want for a few minutes while we're waiting on everyone else. Dun, 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 dun. I've been trying to fight with the, well, I really haven't been trying to fight, to tell you the truth, but I've been trying to encourage the department to put lecterns in the rooms. Do y'all know what a lectern is? It's like a podium, you know? Because ideally, I would like to have this thing like this and be able to stand up and talk and see everyone. But they have this big problem with lecterns, apparently. They think that it's, yeah, like, you know, but it's, I mean, I would understand if this were like a traditional class and I were up on the board. But with the way I do it, I think it would be better. So, I don't know. Okay, it is time. Let's, I sent out an email of the review, and I brought copies. Who doesn't have a copy with them? Why? No, I'm kidding. Here you go. So I'm calling you out. You want the honest answer, or you gotta say give me the light? I only brought 15 copies, so anyone else? Everyone else has it? Okay, well, we're not quite ready to start the review yet. There's a few more things that we still need to talk about. We finished up class last time talking about simple interest, right? And, oh yeah, we have a test on Thursday, right? Everyone's aware of that? Okay. It's going to be on Thursday. So Exam 3, Izzy, it's going to be all right. Exam 3 is Thursday. And what date is that? 14th? All right. And the review is what you should use to get ready for that exam. All right, let's get now to the simple interest that we had talked about last time. For simple interest, we had a formula, A equals P times 1 plus R over N raised to the NT, right? That was it. And we used it. There were two problems I believe I did. One of them was to show the how long it would take to double our money. Remember that? And then the other one was I was just showing you, like, if you hit the lottery or the guy who played poker and won, how much they could make on interest. So it's just two uses of that formula. But I want to do something a little bit different than that now. I want to ask a different question, but it requires us first to look at a second formula, okay? So just keep in mind that this is the formula that we use when interest is compounded n times per year. And I remember we talked about that, right? I said if they say they're going to compute or compound the interest monthly, it doesn't mean that every month they give you the full interest on the entire amount of money. It's they cut up the money and they cut up the percentage. Y'all remember me saying that? And at the end, it really didn't make much of a difference. Well, it actually turns out that there's a second formula that's used more often than this one. And it's the following formula. A equals P. So far it's exactly the same. But instead of that 1 plus R over N all raised to the NT, it's E. Remember E? That's that natural exponential function. E to the RT. And if anybody here uses Pert shampoo, you all have heard of Pert shampoo before? That's a way you can remember that, Pert. Okay, that's the shampoo formula. Now, this is what we use when interest is compounded what we call continuously. And that's somewhat of an odd concept. What's happening is that with this formula, you're actually compounding the interest all the time. Not every second, not every minute, all the time. It's always compounding. But the issue with that is that you're compounding it almost infinitely many times, but you're cutting it up into infinitely small pieces. So I can't really explain to you in this class, I don't want to explain to you in this class where that formula comes from, but I'll just say it's a calculus problem, and it's basically taking this part of the formula we had before and basically letting the n go to infinity. If you let n go to infinity in that formula, which is something you would do in calculus, let that go to infinity, then what comes out is that e. So E actually comes from that. So we won't get into the details, all right? That's just realize that continuous compounding means you're always compounding, which you would think, again, would be the best option for you. It turns out that it is, but again, it's not significant. We're talking pennies here of a difference. And that's what they use. Most banks will use that formula because it's the easiest to work with, right? That other one's kind of ugly, R over N, 1 plus 1, all that. The other one, it's just really 3 numbers. They need to know how much you put in, P, right? They need to know the interest rate, and they need to know the time that you're going to leave it in there. That's all they need, okay? Everyone understand there's 2 different formulas for 2 different scenarios. If you look at your review now, I would like for you to look at number 12. That's what I'm going to do as an example. Well, I'm going to do something like number 12. I don't want to do exactly number 12, all right? It says, what interest rate would you need to turn $8,000 into $9,000 in 3 years if interest is 1, compounded daily, and 2, compounded continuously? So what this means is that I'm asking you 2 separate questions. The daily one is going to require you to work with the top formula here, the first one. The continuously means you're going to have to work with the second formula, all right? And in both of them, what am I asking for? For you to find the interest rate, okay? So let me do a problem similar to number 12. That way you'll have number 12 to do on your own, all right? All righty, here we go. So I'm even going to put number 12 so that kind of follows the review. So what interest rate would you need to turn, let's say, $4,000 into $4,800 in 2 years if interest, man, is compounded 1. Let's go weekly. 2, continuously. Everyone with me? All right, let's do part 1. So for part 1, what formula will we use? The first one, because it's weekly, right? The only time we ever use the second formula is if they tell us continuously compounded. So I'm working with this formula, A equals P is 1 plus R over N raised to the NT. I should get my calculator out. Let's identify the pieces of the formula that we have. We're not going anywhere, Izzy. We're hanging out still. Sorry. What do we know? Help me out here. What do we know in this problem? Okay, my principal is 4,000. That's how much we're putting in to start. Okay, what else do we know? $2 years, that's what variable there? T is 2, okay. What else? Okay, good. A, we know the amount that we want at the end is 4,800. Is that okay with everyone? Yeah, weekly means how many weeks in a year? 52? Okay. What I would expect everyone in this class to know, how many months there are in a year? 12. How many weeks? 52. How many days? 365. And then let's forget the leap years. Banks actually use a different number usually, but we'll do 365. And then, I mean, that's pretty much all I'd ever ask you. Monthly, weekly, daily. All right? Oh, yeah, quarterly. What's quarterly? If I do it quarterly, how many times would that be in a year? 4 times. Okay, 4 times. Every 3 months, but that means 4 times. Okay, so in this problem, weekly was 52, but what variable is that in the problem? That's the n. The n is the number of compounds. Now, it's weekly, right? So I put 52. Something important here. Even though I'm leaving it in there for 2 years, right? That doesn't mean I take weekly and multiply by 2. The n is always how many times it's compounded per year, regardless of how many years it's in there. Okay? All righty. And what is it that we're trying to find? Interest rate. So R is what we want, right? R is the question. So let's plug everything in and then try and solve for R. Okay? Let's do it. So I have 4,800 equals 4,000. 1 plus R I don't know over N, which is 52, and then raised to the 52 times 2. This is a strange equation. We have not dealt with something like this in quite some time. What I'm trying to do is solve for R, right? R is trapped inside of parentheses. Notice that it is not in an exponent, right? It is not in a log. So this is not an exponential equation, not a log equation. This is just a regular algebraic equation. We're just trying to get that R by itself. So the way we'll do it is we'll try and isolate what's in the parentheses. So how do we get that parentheses by itself first? Divide. Yeah, divide both sides by 4,000 first, because that was multiplication there. So take your 4,800, divide that by 4,000, do that on your calculator, 1.2. I'm also going to multiply 52 times 2 and get 104. And this is a strange issue now. How can I get rid of the power on that parentheses? And let me help you. What if it was squared? What if that was all that squared instead of to the 104th power? What would you do to get rid of a squared? You do square root, right? So the way that we get rid of a 104th power is to come in with the 104th root. Now you're going to be asking me in a second, how in the hell do I do that on my calculator? I'll help you, but let's just follow through first. I'm going to take this side of the equation and take the 104th root of 1.2. And over here I'm going to take the 104th root of 1 plus r over 52 to the 104. Questions? No, you don't. Well, the thing is, if we do a plus or minus, right? I mean, technically it's an even root, so you should do it, but that's going to change our interest rate to be basically positive or negative, and our rate won't be negative. So we'll only have to look at the positive case. But if you want to be precise, yes, we can throw it in there. Okay. So what happens on the right side? The root and the power cancel, so you're left with 1 plus r over 52, right? That's what we wanted. On the left side, we need to figure out how to do that. So your calculator, usually your calculator won't have a 104th root button. So let me show you how I'm going to do it. Hold on, I think my phone is not silent. Let me make it silent. Oops. Okay, so let me do this over here. If you're trying to do the 104th root of 1.2, that's the same as taking 1.2 and raising it to the 1 over 104. Now, I'm going to put the property underneath this to remind you. It was this property. The nth root of x is equal to x raised to the 1 over n. Does that look like a familiar property? Maybe you went back when you were doing radicals, back in 03. The nth root of x is x to the 1 over n. Just like the square root of x is equal to x to the 1/2. We said raising something to the 1/2 was the same as square root. Now, how you type this on your calculator is going to depend on your calculator. So I'd like for you to try it yourself. See if you can get the see if you can do this on your calculator, and I'll tell you what the correct answer should be. If you're not getting that, you need to let me know. You should get 1.00175. That's how far mine goes. Okay. Anybody not getting that? I'm going to come around and help you if you're not getting it. Oh, let me turn on the light. Okay, hold on. Okay. Your key, your key for caret, where the heck is it? Is right there. Okay, so let me just show you how it works. Go to, that's your caret. I think it is. Hold on. 3, enter. So you just did 2 cubed. That's your power. That's your caret, basically, okay? But on this calculator, what you're going to have to do is you're going to have to figure out what the power is first. So you're going to have to figure out what's 1 divided by 104. And you're going to need to write that down, and then that's what you're going to use in your caret. Like 1.2 and then caret in that number. See if you can get it. All right. Okay, yeah, same thing. Your caret key or raise key is at y to the x. So let me just show you how it works. 2, hit 2, then that key. That's raised, and then hit 3, equals. So that was 2 cubed, okay? What you're going to have to do is, let me get through here. You have to do 1.2 raised to the 1 over 104. You need to first find out what that is. So just go ahead and type in 1 divided by 104. What is it? So you're doing 1.2 raised to that. So you're going to have to do you're going to do this first, figure out what that number is, write it down, and now do 1.2 caret, which is that y to the x, and then now 0.009615384, and you should get that. Got it? Okay. Hey, it's okay. Yep. Oh, you put 405. It's 104.
Oh.
Try it again. Let me see. One. No. You can do it all at one time. You do your 1.2 raised. 1 divided by 104. 1 divided by. Yeah, you can. There you go.
Oh, so I was doing the 104 per root.
Yeah. Who else? Everyone else good? We're all good? Get it figured out over here? Yes? Okay. All right. Everyone's okay. We're moving on. If you don't have a calculator and you used your phone, you better go home and figure it out on your calculator, because on Thursday you can't use your phone, right? All right, so here we are, back to this equation. Now this equation is going to be pretty clean as far as solving from here. We're just going to try and get the r by itself. So we're going to subtract 1 on both sides. Okay, when you subtract 1 on both sides, you get 0.00175 equals r divided by 52. You all still with me? Multiply both sides by 52 now. Yes. Did I put one, did I what? Oh, you should go as much as your calculator goes, but I wouldn't go more than like 6 decimal places. Yeah. I mean, 6 would be acceptable as a max. You don't have to go, because some of your calculators are set up to go like 10 decimals. We don't really need that. Multiply both sides by 52. 0.091. And I am aware that our answers may vary on the test, okay, because of the way you round. That's why it's important for you to show your work. But we should all be pretty close. I multiplied both sides by 52 here. No, multiply, because it's already in the denominator on the right side, so I multiplied to get rid of it. Right, multiply both sides by 52. Now we need to convert that rate, that decimal, into a percentage. So it's opposite of the way you do it, right? You move the decimal point where? 2 places which way? To the right. So 9.1%. So if you're thinking you're going to walk into, a bank and put some money in there, and in 2 years go from $4,800 to gain $800 in 2 years, you're going to need a 9.1% interest rate, which is probably not going to happen. Questions? We need to move on to part 2. Part 2. Part 2, the only difference is that we're using the other formula, which is the shampoo formula. A equals P e to the RT. And we know the same things. We know the amount that we want. The amount that we want at the end is 4,800. We know that our principal started out at 4,000. We know that the time we put it in there was 2 years. We want to know the rate, right? And see, notice in this formula for continuous compounding, there is no n. Okay, it's already taken care of, which is why we like using it. So let's fill everything in. 4,800 equals 4,000. E to the r, we don't know. T is what? 2. Yeah. Thank you. Pardon me? R to the 2. No, because this is multiplication. Right here, that's multiplication. So it's 2 times r, not r squared. It's. Oh, yeah. You can, yes, you could say r times 2, but we usually put the number in front of the variable. Everyone okay with that? Now, the rate that we're trying to solve for, notice where it is. It's in an exponent. So how do we get variables out of exponents? Log. We're going to need log at some point, right, to drop it out. But we have to wait until the exponent, the base and everything is isolated. So divide by the 4,000 again. 1.2, same result. E to the 2r, right? Questions? Now, I'm going to come. I divided both sides by 4,000? Valerie? Yeah? Okay. So I want that 2r, right? I come in with what log on both sides? Yeah, the natural log, right? That's what I was trying to get y'all towards the end to see, that anytime you want to drop something out, always just come in with the natural log. But something really nice is going to happen here. And it will always happen with these problems. Does anybody remember the property of logs? When you take natural log and e and put them together like that, what happens? They cancel out. Good. They kill each other off because they are inverse functions. Remember, the e is that special base and the natural log is that inverse of it. So when you put them together, they kill each other off. So the right side just becomes what? 2r. And the left side becomes natural log of 1.2. So what we're going to do is now find what is the natural log of 1.2 on our calculator. I get 0.182322 equals 2r. Last step would be divide by 2. And when I divide by 2, I get 0.091161 for r, which is about what? 9.1%. Same result. Which one do you prefer? The second one? Y'all agree that that's easier? You like the first one more? Really? Okay. This is the property right here that I was using. We had a property that said anytime you have natural log of e to the x, the answer was x. So whatever's up here winds up being by itself. The natural log and e kill each other. All right. I want to help you on 13, but I don't want to do the whole problem because we don't have time. So let's look at number 13. And I'm not going to write it all down. How long would it take to double your investment if you put money into a simple interest account at 3.75% if the interest was compounded monthly and continuously? So I'd like to change the problem a little bit. I want to triple. Man. I want to triple our money. I'm having lots of issues with my thing today because I'm using my wireless thing, which is pretty cool because I can be like completely anywhere in the room like this. That's pretty neat, right? but it slows down the computer quite a bit because I've got too many things running. So, like a year ago when I first started using this, is the way I was doing. I was walking around the room and I was doing it, but I just got tired. I'm sorry, Izzy. I'm sorry, bud. I'll get out of your space. I'm in your personal space. I'm sorry. All right, so I want to triple our money. And let's say we have an interest rate of 4.2%. And let's just say continuously. And you know what? On your review, scratch out monthly on number 13. I will not ask you that. I will only use continuously on number 13. So don't go home and try it because it's going to be really kind of a challenge, all right? Everyone understand I've changed 13 to this? We want to triple our money at that rate, and we want to do it if our interest is compounded continuously. What formula do I use? Okay, shampoo, right? Bert? What do we know? I know my rate. What's my rate? 4.2%, but I can't use it as a percent. 0.042. Everyone okay with that? What else? Yeah, see, I didn't tell you how much money I'm putting in, right? 3 times what? 3 times P, right? Isn't the amount that you want at the end 3 times what you put in? Yes? And P is just P, right? P is how much we put in. And I'm not going to even tell us. What's interesting about this problem is that if you want to triple your money, it doesn't matter how much money you put in. If I put in $10 or $10 million, it'll take the same amount of time to triple it at a certain interest rate. Now, what is it that we do want to know here? The question says, how long will it take? Time, right? T is what we want. T is our question. All right, so let's rewrite the formula. What will the left side become? 3P equals, now P is just P, I don't know what that is, right? E to the R, do I know R? 0.042, and then T, do I know T? No, but that's what I want, right? Make sure you put that rate as a decimal, right? If you put 4.2, it's going to be all out of whack. That would be like you have a 420% interest rate. And yeah, that's in a different universe somewhere. All right, how do we solve for T? Same way we just did, right? In the last problem, we divided both sides by 4,000. Here, what will you divide by? P. Divide both sides by P, the P goes away, doesn't it? P divided by P is 1. So we are left with what? 3 equals E to the 0.042 T. See, so if I say double your money, the only difference would be what in this problem? It would be a 2 where the 3 is. If I say quadruple your money, it'd be a 4 instead, right? The P is always going to cancel. What would my next step be? Natural log on both sides. I have natural log 3 equals natural log e to the 0.02 t. And good things happen on the right side. Cancel out. I get 0.042 t. Left side is natural log 3. So I'm going to have to find out what the natural log of 3 is. Then I'm going to divide it, right, by what? 0.042. Ooh, okay. I get 26.1574, something like that. After, well, I did natural log of 3, then I divided it by the 0.042. So approximately how long is it going to take? 26 days? Years. Remember, time is always measured in years in this formula. So it's going to take 26 years to triple my money. You think you could handle that? I give you a different, I say double or quadruple or something like that. Give you a different interest rate. Think you could do it? Okay. All right, now the last type of problem that you'll see on the test. I know a lot of you are hooked up to the grid. You can search, get on your phones and search. So somebody, please look up the half-life of carbon-14. Go ahead. Yes, but I need to know what's, it's on, I wrote it on here. Ah, man, I forgot I wrote it on here. I wanted y'all to surf the web in class. Be resourceful. Well, okay, does anybody know what carbon-14 is? What carbon dating is? Have you heard of it before? Okay, basically every living thing has carbon-14 in it, right? We all have carbon-14 in us. As soon as we die, the clock starts and our carbon-14 starts to decay, starts to go away. Right? Starts to go away. And that the rate at which it goes away is exponential. So we start out here at some point, sometime 0. And at that point we have 1 or 100% of our carbon-14. So I'm alive, right? That would be times 0. I'm alive. I have all of my carbon-14, all 100% of it. Okay? Then I die. As soon as I die, carbon-14 starts to go away, and you don't have a test on Thursday, so it's all good. No, right? Carbon-14 starts to go away. It takes 5,730 years for half of it to go away. So remember that example? Did I do that example where I tore the sheet in half? I can do it again. If this sheet represents all of the carbon-14 I have in my body, then 5,730 years later, half of it's there. So if I draw 5,730, then I would have half of it. Okay? Then another 5,730 years later, half of it's gone again. So that would be a quarter out here. And that keeps happening forever and ever, right? So what we get is this exponential function. Oh, wow, that's wobbly. And it's asymptotic, meaning that it approaches 0, but it never gets there, because it's always half of it, half of it, half of it. So the way that carbon dating works is that we go find a bone, right, or something that used to be living, and we measure very accurately how much carbon-14 is in it. If I find that half of it's there, half of its carbon-14 is there, then how old is the bone? 5,730 years old. If I find a quarter of it, then how old is it? That'd be half, so that means 2 of those time periods. So it'd be like 11,000, 12, whatever. Make sense? So the smaller the percentage, the older it is. But that's what we use. It's not a perfect way of dating things, but it's a very good way of dating things. We can see, very, very old things by carbon-14. So here's the question. If we're going to use this, we know it's exponential decay, then we know that I'm going to tell you, we can use this equation to model carbon-14. How should I do it? I want to try and make it similar to the PERT formula. The amount equals P e to the KT. This is for carbon-14 dating. Now let me explain. Does that look like PERT? It's PECT, yeah. So let me explain things. First of all, P, we're going to say P is the amount of carbon-14 at start. A is the amount of carbon-14. I'm just say C14, okay? C14 at the end. T is time in years. And K is what we call the decay constant. So K used to be what? In our finance, it was R, it was the rate. It was how much our money was growing by. In a problem like this, the K is not growth, it's decay. So it's the rate at which the carbon-14 is decaying. With me? Okay. P is the amount of carbon you start with. A is the amount at the end. So basically, P will always be what? How much do you start with? That's when you die, right? How much carbon-14, or when it dies, how much should it have? All of it, right? 100% of it. So P for us is always going to be 1. A will be how much is left when it's found. So A is the amount at the end, when found, when discovered, whatever. So they dig up a bone somewhere, they measure it. So we'll always need to know how much is there when they find it. Go ahead. Yeah, that's fine. Okay. Bye, Izzy. Take it easy. What we need to determine here is what K is. That's our decay constant. And the decay constant is always the same thing for carbon-14. But if you take something different than carbon-14, that decay constant changes. I guess what I'm trying to tell you is that this formula works for all decay, all exponential decay. If anyone's familiar with radioactive material, plutonium, uranium, bad stuff, right? Those have half-lives also. That means how long it takes for half of it to go away. Carbon-14 is 5,730 years, but there's some radioactive isotopes that it takes tens, hundreds of thousands of years for half of it to go away. Like Chernobyl, exactly. I want to talk about Chernobyl. I don't know if I'll have time. But so what I'd like to do right now is I'd like for us to find the decay constant for carbon-14. And then we'll answer the question on the test, on the review. All right, so to find the decay constant, here's what we know. We know the half-life is 5,370 years, right? That's what it says. So here's what I can say from this. Since half-life is 5,730 years, that means I can write the following equation. And I want you to try and help explain why. Why can I write that? But where am I getting all this from? Like, okay, so the A here is the amount I should have at the end, right? So half of it should be there. If I start with all of it, right, half of it should be there at the end in how much time? 5,700. The only thing I don't know is K, right? And that's what we're about to find. We're about to find the K. So can you solve that for K? How would you solve that for K? Divide by 1, which really wouldn't change anything, right? So we still have 1/2 equals e to the 5730k. Natural log on both sides. Natural log of 1/2 equals natural log of e to the 5730k. The right side is nice. It's 5730k. But the left side is natural log of 1/2. You should not get 0. If you get 0 for natural log 1/2, you didn't use parentheses. It should be negative 0.693147, something like that. What can I finally do to get k? Divide by 5730. You should get this. I have to put it up here. K equals negative 0.000121. Now, does yours have like E or something like that? Yep. Remember, E, that little E thing means move it over. In your case, since it's -4, 4 decimal places to the left. That is how you find the decay constant for carbon-14. So here's our final result then. The amount that would be there if you find some sort of bone follows this equation right here. Where's the P? Why not? P is always going to be 1, okay? For these problems with decay like this, P is the amount that was there to start. It's always going to be 1. 100% of the carbon-14 is always going to be what we assume it had as soon as it died, right? It had all of it. So I've boxed the formula that you would use on the test right there. You will not have to regenerate and find K again. We only had to do it one time. So this is our new formula. If you don't write that down on your cheat sheet for the test, then you are going to have to find K again. So let's answer number 14 now. 14 says, a bone is found to have 0.825% of its carbon-14 remaining. How old is the bone? So I think I'll change the problem a little bit. Let's say we find a bone that has 0.3125% of its carbon-14. How old is it? So we are using the formula A equals e to the negative 0.000121, right? T. We want to know how old, right? So we want to know what T is. The only thing we need to know is the amount of carbon-14 that was there when it was found, which for us is 0.3125%, right? Yes, you have to convert that to a decimal. Questions? Now what? Trying to find T. T is trapped in an exponent. Natural log. Natural log 0.003125 equals natural log of e to negative 0.000121 T. Natural log e cancels on the right side. so you get negative 0.000121 t. Yeah, you have to do the other one on your calculator. Negative 5.76832, and then divide both sides by negative 0.000121. What do you get? Close to what? Anyone? Anyone? 47,000. I'm getting 47,672 is approximately T. We know it's about 40, 50,000 years old. That's the way it's done. Questions? Think you could handle problems 12, 13, and 14 on the test now? All right, let's talk about the rest of the review in the last 20 minutes we have. There were no questions on that one? We're good? So remember, you got to convert that to a decimal. Let's look at number 1. Find the inverse. Y'all remember how to do this? I don't think I have enough time to go through all these, so I can talk through them. What would you all prefer? Do y'all want to like pick the ones for me to do until we run out of time, or which ones would you like to see then? Which one? 2? Number 2? Verify that these functions are inverses. How do you verify that 2 functions are inverses? You have to do Fogg and Goff. So I'm going to write it like this. The other one I'm going to call G instead. Just keep note that I changed that F inverse to a G. That way I could do Fogg and Goff. So you must show on the test, this is what I want to see, that F of G of X turns out to be what? If they're inverses and you plug X in and go through both of them, what comes out? If you plug X into a function and then it goes through its inverse, what comes out? X. The whole idea is that whatever F does, the inverse undoes it. So if X goes in and goes through the whole thing, comes out X. You have to show that, and you also must show the other direction works too. So let me try these. F of G of X means you have to do F and inside G of X, which means F and then inside of that, G. Right, that's G going inside, right there. And now that negative 7 plus 1 over 5 is going to get plugged into F, right? Wherever I see an X, and I see an X right next to a negative 5 plus 1. So this is going to become equals negative 5, then inside of that, negative 7 plus 1 over 5. What am I still missing here? Plus 1 next to this, then the whole thing divided by 7. Does everybody see that? That's your negative 5x plus 1 over 7. What happens there? What happens with that negative 5 and that 5? They cancel out, right? This 5 right here and that negative 5 cancel. I'm still left with a what, though? Negative 1 or a negative sign, right? Distribute that negative sign through the top, and what would you get? Changes your signs to be positive 7x, then what? Minus 1. Then you have that plus 1 sitting out there, and then all divided by 7. The 1's cancel. You're left with 7x over x, 7, and that's x. Check. It works that way. See it? We've done these, right? Let's ring a bell. Seems like forever ago. The other way is that you take G, and this time you plug in F, which means you take G, and inside of it goes the negative 5x plus 1 over 7. And then you do the rest at home, okay? It should come out to be x. All right, what else would you like to see? 4? 3? Okay. Dot, dot, dot. You finish that one off. Number 3. Number 3 says graph f of x equals 4. You actually don't need the parentheses around the 4. Now here's what I expect for this. This is the problem where you have to shift the thing around, like up, down, left, right. Okay? But you need to know what the base function looks like. You need to know what 4 raised to the x is. So to do that, I would like to see a t-table. So give me a t-table, x, 4 to the x. What numbers did I say to always plug in? Negative 2, negative 1, 0, 1, 2. If you do that, you get 1/16, 1/4, 1, 4, and 16. Then you make your graph. And at 1, you're at 4. At 2, you're way off the charts up at 16. At 0, you're at 1. So like this. With an asymptote like that. That's what 4 to the x looks like. And I remember giving you a homework assignment where you had to go home and do a couple of these, right? So everyone can make a t-table off something like that. Now that's not my answer though, right? What do I need to do with that graph? I need to move it around, right? So where do I move it? What does the minus 2 up here tell me? Opposite of that. So is it up to? Right 2. So the one that's up there with the x is left and right. That's to the right 2. So this means right 2. And then this one over here means down 3. So I'm going to take that red graph and move it to the right 2 and down 3. So I can grab any of the points, move them right 2, there, oh, down 3, put me here. Take this one to the right 2, down 3, would be here. Where's my asymptote going to go? Where's that dotted line? How much is going to go down by? Goes down 3, right? Everything goes down 3. So if this was 1, 2, 3, everything goes down 3. So it'll be that same graph like this. Does that answer your question or not? What? No? How to what? Okay, I just went to the right 1, 2, right? And I moved down 3. Well, that's kind of off. Down 3 right here. Remember that this from here to here was 4, right? So that's 1. So to move down 3 means to move down this much. To the right 2, down 3. And then same with this point, to the right 2, and then down 1, 2, 3. That better or no? And the asymptote just went down 1, 2, 3. Now, look at number 4 on the test. What do I want you to graph there? I left something out there on that. I left the f of x, but you're supposed to graph this, right? So how do you graph log base 4x? You take the table for 4 to the x, right? And you flip them over. So if you do number 3, number 4 is just going to be an immediate result. And I'll make it like that on the test. Whatever the base is in number 3 would be the same base you would have in number 4. So you wouldn't have to even make a new table. That's just going to check to make sure you know that to graph a log, you flip the exponential function's coordinates over. Oh, shit. Oh, I just said, oh, shit. Oops. It's not the first time. Anything else here? That's kind of popping out at you like, uh-oh. 7? So numbers 5 through 11 are all solving equations, right? Number 7, log base 4x minus log base 4 x plus 4 equals 2. So the way we solve log equations is to use the loop. But you can only do that if you have a single log by itself. So we're going to try first to put these 2 logs together, right? 2 logs with subtraction becomes 1 log with division equals 2. Now, loop-de-loop time, right? Make sure the only time you can do the loop is when you have that log and everything inside of it by itself. So nothing else is out there, right? Like I don't have like a 3 out here. I don't have like a plus 4 in there. The log is isolated completely. Now I can come through here and I can, pardon me? Yeah, you would just have to get it by itself first, that's all. So this means what? What do I write? 4 to the second power, right? Not 4 times 2. 4 times 2, that's going to cost you a lot of points on the test if you do 8 instead of 16. So I have 16 equals x over x plus 4. This is a rational equation. They can't because I have 2 terms in the denominator. Multiply both sides by x plus 4. And that allows me to cancel out the x plus 4 on the right. On the left side, I have to distribute the 16 through. (16x plus 64) equals x. Linear equation here, right? Just get all your x's on one side, everything that's not x on the other. So 15x equals negative 64. I'm subtracting x on both sides, subtracting 64, right? Yeah, but I brought that x over by subtracting it, and then I subtracted 64 to move it to the other side to finally divide by 15. You could leave this answer, or if you wanted to, you could do a decimal. Approximately negative 4.26666666. Yes. Oh, like had you moved it the other side? Oh, yeah, yeah. Because you would be doing positive 64 divided by negative 15, which is the same as negative 15 divided by positive 64. Oh, wait, no. You would have negative. Yeah. Okay, what else? Anything else there? Do what? Okay, number 8. All right, this is a good problem. It's a log equation, which means normally we would use the loop, right? But that means we have to have a single log by itself on one side. Well, on the left side, I can put these two logs together. That'll become a single log with what? Two logs being added turns into one log with multiplication, right? X times x plus 4, which will become x squared plus 4x. I'll do that on the next step. Equals log base 3/8. So I have log base 3 x squared plus 4x. Don't the what? Yeah, the bases have to be the same. They are, right, in the problem? Oh, yeah, I forgot it. Yep, thank you. Sorry, I just forgot it. Thank you. I'm not. I'll be on top of it here. What now? Mm, this is what? Yes. Yes. If we have log of any base of x equals log of any base equals y, or log of any base y, or if those two are the same, then that means that the x must be equal to the y. This was the case where if we do have logs on both sides, we don't need the loop. All we do is we set the insides, which are the 8, equal to each other. X squared plus 4x equals 8. The logs basically just go away. They have to have the same. I'm not going to give you anything else like, different, but the important thing would be not to be trying to do the loop at this point, because it's really not going to get you anywhere. Well, technically you could, but it's too much work. What type of equation is this? Quadratic. So you bring everything over to one side, quadratic formula, which I don't plan on probably ever solving another quadratic equation in this class. So, yeah, well, because we'll call it trivial at this point. 0.46 and 1.46. So after you use quadratic formula, you should get approximately negative 5.46 and positive 1.46. Everyone understand that there's sets of steps in there you'd have to do? I'm not cheating. Well, your calculator has, if it has a solve feature, you can do it. Yeah. Read the manual. No. I could show you I could show you after class. It's not, I don't mind holding, you know. I'd rather you know how to do that than not, but. Okay. Yep. Questions on that? All right, we only have a few more minutes left. Let's talk about the cheat sheet. Same policy as the last test. 1 8.5 by 11 sheet of paper, front and back. You can have steps, procedures, hints. No worked out problems, right? No worked out problems. I don't plan on putting any of these answers up. So you ask me. If you're not sure about your answer, you can ask me. I think this might be a bit long. Yes, I don't plan on throwing anything crazy different at you, you know? Y'all really want me to put the answers up? God, man. Give me more work now. No. I will work on that. Jeez. Just the answers, right? Okay, just the answers. Worked out? All right, I'll do that. Oh, Chernobyl. We'll talk about it another time. I don't have enough time to talk about Chernobyl.